So yesterday when we finished, we got where we stopped, we had two equations. One was based off differentiability, one was based off continuity. We went as far as we could because we had A and B. Okay. So our last step is to actually figure out what A and B are. So we're going to do it the same way we did number 3 yesterday. Okay. So let me get some more room here. Let's see. There's that. And where's the other one here? Okay. Okay. So there are the two equations that we had finished with yesterday, right? So we did elimination on example number 3. We used elimination, right? Put the A's on top of the A's, put the B's on top of the B's, the equal signs on top of it, and then try to cancel that one out. Well, there's another way to do it. There's another way to solve. It's called substitution. Either one works, elimination or substitution, but substitution works best when one of the letters is already solved. We have A is already solved. So what we're going to do is take what it's equal to. A is equal to this, right? A is equal to negative 20b plus 3. They're the same thing. So in the other equation, I'm going to plug it in. Everywhere I see an A, I'm going to plug in that value. That's another way of solving it, besides elimination like we did yesterday. Okay, so I'm going to rewrite the bottom, but instead of A, I'm going to write negative 20b plus 3. Okay. So let me rewrite the second one. So negative 5 parentheses. This is where I'm plugging in negative 20b plus 3. Everything else stays exactly the same because it doesn't have an A. Elimination would work for this one. Elimination would absolutely work for this one. And if you want to use elimination, go for it. But I think this one's better set up for substitution. And I've never done substitution with you guys, so I want to show you that option. Sometimes it's easier to do that. So now, in your new equation, you only have B's. There's no more A's. Solve for B. So I'm going to distribute the negative 5. So I get 100B minus 15 minus 6 equals 50B minus 20. I get 100B minus 21 equals 50B minus 20. Okay, so I'm going to get B's on one side, everything without a B on the other side. So I'm going to subtract 50B from both sides, and I'm going to add 21 to both sides. So I get 50B equals positive 1. Divide by 50. B equals 1/50th. Okay, there's my B. Now what I can do is take that B and plug it back in up here and solve for A. So we're going to plug in B there and solve for A. So A equals negative 20 1 over 50. So I get negative 20 over 50 plus 3. Negative 20 over 50 is the same as 2/5. So if I add negative 2/5 plus 3, I get 2 and 3/5, which is the same thing as 13/5. Okay. That's another option. That's substitution. So that method was called substitution method for solving more than one equation, systems of equations, because we had 2 equations. Okay. The one we used for example 3 was called elimination method. They both work the same. Sometimes it's easier to use one, sometimes it's easier to use the other. Okay. So it's called, let me write it down, elimination method. Okay. All right. Okay, so now let's look at equations that are a little bit different than the ones we've done before. It's the same thing. So we're doing the same exact thing. We're just looking at different types of equations. Okay. So number 5. Given the piecewise function defined below, answer the question at the bottom of the page regarding continuity. So the question is about continuity and differentiability. Is this continuous? Is it not continuous? Is it differentiable? Is it not differentiable? Okay, that's what they want us to answer. All right, so let's start with continuity. Same thing we did last chapter. So where is the only place on f of x that I'm concerned about continuity? 0. That's the only spot I'm concerned about. So I'm going to check 0. Okay. So the limit as x approaches 0 from the left for f of x, the limit as x approaches 0 from the right from f of x. If those two are equal, then the overall limit, that'll be the overall limit for 0. And then f of 0, the y value at 0. Okay, so I'm going to solve each of these. So to find the limit as x approaches 0 from the left, that's the less than side, right? I'm going to use the top guy because that's the less than, right? So I'm going to plug in 0 everywhere I see an x. So 3 times the natural log of 1 minus 2 times 0 plus 1. Negative 2 times 0 is just 0. So I get 3 times the natural log of 1 plus 1. What is the natural log of 1? It's something you're going to see, we've seen before, and you're going to see more and more. So what is the natural log of 1?
0.
Yeah, it's actually 0. Why is it 0? Because that's what it's asking, right? What is this equal? That's what we're asking. What is the natural log of 1? Well, I can rewrite natural log to log with a base of e, right? It's the same thing. So what they're asking is e to what power gives you 1 as an answer? E to what power makes 1? Well, what's the only power? You have to be 0, right? Anything to the 0 power is always 1. So that's why the natural log of 1 is 0. So we get 3 times 0 plus 1, which equals positive 1. So the limit as x approaches 0 from the left for f of x is 1. Okay. Now let's go from the right. We're going to use, the right is the greater than side. The greater than side. So we're going to use this guy here. All right, so we're going to plug in 0 there. You could probably do that one in your head. Negative 6 times 0 plus 1. Negative 6 times 0 is just 0. Positive 1. So those two guys are equal. That means the overall limit has to be 1. What would f of 0 be? I've actually already done it. It would also be 1, right? It's the same thing as the bottom because the bottom is the equal. Got the equal sign. So it's continuous. So it's continuous at 0. Is it differentiable? Just because it's continuous doesn't mean it's differentiable. Okay? So we have to check that as well. Let me... Okay. Okay, so... Okay. Differentiability. So remember, to check differentiability, it's not as bad. It's is the derivative from one side the same as the derivative coming from the other side? Well, before I check that, what do I need to do? Find the derivative. So I'm going to go up here, and I'm going to go find the derivative of f of x, f prime. So the bottom's easy. The bottom's just negative 6, right? Negative 6 for x is greater than 0. That's the derivative of the bottom. The top isn't that bad either, but it's going to take a little bit. It's going to take, because it's got the natural log in there. So let me move this. So I'm going to do the derivative. I'm going to find the derivative, give myself a little more room. I'm going to do it over here. Okay, so it's got 2 parts to it. 3 times the natural log, it's got 2 parts to it. So when I find the derivative, I'm going to do it in 2 parts. I got that part there, and then the plus 1 there, right? So I'm going to find the derivative of the yellow first. The 3 don't worry about. The 3 is just going to be in the front. How do I find the derivative of natural log? What does the derivative of a natural log say? What do I do first or second? We're going to rewrite it at the bottom. So whatever was the natural log stuff, so 1 minus 2x, that's going to go at the bottom. What goes at the top? The derivative of that, which is just negative 2. That's the derivative of the yellow. What is the derivative of plus 1? 0. Yeah. So let me simplify this a little bit. We get negative 6 over 1 minus 2x. So that's going to go down here. for x is less than 0. Okay, so that's the derivative. So for the less than side and the greater than side, so I'm going to do the same thing. I'm going to plug in 0 for the less than. I'm going to plug in 0 for the greater than and see if they're equal. If they're equal, it's differentiable at 0. If it's not, that's not. Okay, so C for our problem is 0. Okay. So I'm going to plug in 0. The negative side is the less than side. Less than, plug in 0. Negative 6 over 1 minus 2 times 0. Two times 0, so it would just be negative 6 over 1, right? Negative 6 over 1. Okay. Plug in 0 to the greater than side for the derivative. Well, I can't really plug it in because it's just negative 6. So it would be negative 6. So they're equal. So f of x is continuous and differentiable at x equals 0. Okay. It's the same thing as what we're doing. The only difference between that one and the ones we've been doing is the natural log thing. But we know how to find derivatives of natural logs or e's, right? Those are big. On tests, you see a lot of derivatives of natural logs, derivatives of e's. Those are the big ones that they like to use because technically they're the easiest to do because natural log isn't that bad, right? The bottom is whatever rewritten. The top is the derivative. E repeats itself times the derivative of whatever's on top, or the whatever's the power. Okay. Okay, so I want you to do number 6 right now on your own. Do number 6, and we'll talk about it in a few minutes. So for number 6, I got both differentiable and continuous at x equals 1. Okay. So the last 3 or 4 questions. Last 3 questions are just extra questions that I gave you just as practice if we had extra time. So what I want you to do is let's see. On the last couple questions, they're numbered wrong just because they're extra problems I threw up here. So do example number 2 and example 3. The example number 4 and the last one you don't have to do. So example 2 and 3 on the same page. Do those as practice. So example 2 here, and then example 3 below it. So example 2, is it differentiable? That's it. You don't have to find continuity, it's just is it differentiable? And then number 3 is, it's differentiable. Tell me what A and B are. Okay, and then we'll be done. So example number 2, yes, differentiable. Found the derivative, plugged in 1, you get the same answer, right? Okay. Number 3 is you have to find a and b. So it's differentiable. Okay. So the derivative for x cubed is 3x squared. The derivative for this guy here, remember, a and b are numbers. A and b are values. They're not variables. So for this guy here in yellow, I'm going to use the chain rule. So I'm going to move squared up to the front with a, 2a, subtract a power. So that's how I got 2a x minus 2. And then this plus b part, b is not a variable, it's a value. So the derivative of any value, constant, is just 0. So the b goes away. And then you check like you normally would. So you plug in 1 to the top for the left-hand side. So we get 3, 1 squared, which is just 3. The bottom, you plug in 1. I get 2a, 1 minus 2. And I get negative 2a. That's negative 1 times 2a. Okay. I don't have any b's. So I just solve for a. So negative 3 over 2. Plug that back in to the original. Anywhere you see an a, plug in a negative 3 over 2. What do we plug in for x, though? 1. Then solve for b. So it would be negative 3 over 2, parentheses 1 minus 2 squared plus b. So I get negative 3 over 2 times 1 plus b. Because negative 1 minus 2 is negative 1, squared is positive 1. Wait, we need an equals though, don't we? I didn't put an equals. Oh, I know what to do. Okay. So to solve that, we need equal something, right? Because we need something on the other side to balance it out. Because we get this side here. It's going to be negative 3 halves plus b. But to solve for b, we have to figure it's got to be equal to something. What is it going to be equal to? Well, here we're going to use differentiability. Differentiability, we're going to use continuity. With differentiability, the b went away. So that didn't help us there. But with continuity, the b won't go away. So what I got to do is I got to set up something for continuity. So the limit as x approaches 1 from the left, x approaches 1 from the right, which is equal to f of 1. I dropped the limit, overall limit, because if those two are equal, then the limit is equal. So even though I don't need to check for continuity, I need something to equal it. So I need another equation. So if I plug in 1 to the original, I get 1. If I plug in 1 to the bottom, I'm going to get A times 1 minus 2 squared plus B. And then here I'll also get 1. So this will be A plus B equals 1. Because negative 1 squared is 1 times A is 1, A plus B. So there I can plug in. This is where I'll plug in A, negative 3 over 2. That's the other side of this guy, right? The part I was missing. Add 3 over 2 to both sides. B equals 5 over 2. Because this guy's 2 over 2. So 5 over 2. Okay, so I'm going to give you the practice for this, practice 13. So the next 2 days, what we're going to be doing the next 2 days are 2 things: practice and review. I'll give you the review tomorrow. Let's see. Oops. I'll give you the review right now. I have it printed out. Let me see.